So our project is Where to Meet at Ohio State for ISE 3230, the final project by Nate Rising and myself. So our original problem was given a certain number of team members and the dorms they live in on Ohio State's campus, we wanted to find a meeting location that minimized the total distance traveled by the group. But we realized this problem was too simple from an optimization standpoint. So we expanded the problem to come up with a meeting schedule for a certain number of meetings that also minimized the total distance and was subject to some specific constraints that we will touch on later.
So as Patrick mentioned, the problem allows for a variable amount of people in meetings. So before we did the optimization formulation, we collected some information from the theoretical user. So that included the number of people in the group, the total number of meetings they wanted to schedule, how many buildings on the campus they wanted to consider, the starting locations of each member in the group, and then a list of buildings that they did not want to visit throughout their semester meeting schedule. And then from this user collected information, we built out a distance matrix that identified the distance from element I to element J, and then also this CB vector, which indicates for each building we considered whether or not it's on South Campus or North Campus. And then just a quick overview of how we did the distance matrix. We ended up using 102 different buildings on OSU main campus. We recorded longitude and latitude data, and then we used a formula to calculate the distance between latitude and longitude points. So covering our decision variables, we looked at x of bm, and this is a binary decision variable. So this ended up being a b times m matrix of decision variables. And this indicates whether or not building B was chosen for meeting M. So using this decision variable and our distance matrix, our objective function can be formulated below, where we minimize the distance traveled for each person to each building for each meeting. But of course, for each meeting, only one building is actually going to have a positive distance value because all the other ones will be 0. This is because of this first constraint that says at each meeting, only one building can be used. We also added a few more constraints after we realized our initial problem was a little bit too simple, just to make the problem more challenging. So we said that you couldn't repeat buildings, and you would have to alternate meetings between being on North and South Campus. And then we also said that users could input certain buildings that they did not want to meet in. So this is just a look at the overall formulation.
So for our first example, we selected a group of 3 students for a semester-long project. We decided on 12 meetings, which is essentially meeting once a week for every week, excluding the first week, fall break, and Thanksgiving break. So student 1 lives in Lincoln Tower, student 2 lives in Norton House, student 3 lives in Worthington Building. And then we also chose to avoid Dries Lab, Journalism Building, and the RPAC as meeting locations. As a result, the total distance traveled by the group was 14.102 miles. If you look at the map on the right, the green circles represent the starting locations of each group member. The purple circles represent the buildings that were chosen for each meeting. The red line is the divider between North and South Campus. As you can see, the meeting locations alternated between North and South Campus. For our second example, we wanted to increase things a little bit, so we selected a much larger group of 16 students, but again decided on 12 meetings. In this example, all students lived in North Campus dorms, and some even lived in the same dorm as another group member. Also in this example, we decided to avoid all North Campus dorms as meeting locations. So as a result, the group traveled 43.7 miles in total. Again, looking on the right, you can see the starting locations for each group member and the meeting locations that were chosen. So that's our project. Thank you very much.